Good morning all. So in today's class we will look at case 3. So that is a case when the roots are equal. So let me take the roots to be roots equal ആവുന്ന കേസിൽ real root ആയിരിക്കും. So we will have m1 equal to m2 equal to say m, which is a real number. Then in that case we have only one solution, which is of the form x equal to a raised to mt and y equal to b e raised to mt is a solution of the linear system. Now we need to look at what is the second solution. Now when you have two equal roots, the second solution will be of the form x equal to so the second linearly independent solution is, so that will be x equal to, so it is in the form a1 plus a2t e raised to mt, and y will be equal to b1 plus b2t e raised to mt. Now we need to find the values of a1, a2, b1 and b2 such that it satisfies the given linear system. For that we will substitute the value of x and y into the given equation. Then solving, we will get the value of a1, a2, b1 and b2. So that will give us the value of the second solution. When you take the linear combination of both the solutions, that will give the required general solution. So the general solution is x equal to, so that will be c1a e raised to mt plus c2 a1 plus a2t e raised to mt, and y will be c1b e raised to mt plus c2 b1 plus b2t e raised to mt. Now the constants a1, a2, b1, b2 are obtained by substitution into the given equation, by substituting in the linear system. So that's how we solve for So let us now look at an example of solving a linear system where you have equal roots. So the problem is to solve dx by dt equal to 3x minus 4y and dy by dt equal to x minus y. So as we have done in the previous problem, so first we will substitute x equal to a e raised to mt and y equal to b e raised to mt. So substituting into the given linear system, these are the two equations we will get. So dividing throughout by e raised to mt, we will get m minus 3a plus 4b equal to 0, a plus minus 1 minus m b equal to 0. So we will get a non-trivial solution when the determinant will be equal to 0. So determinant, so upon taking the determinant, you will get the equation m square minus 2m plus 1 equal to 0. So that is m minus 1 whole square equal to 0. So you have the root 1. So that is the only root. Now m in the value, നമ്മുടെ ഈ equation substitute ചെയ്യുക. So we will be getting 1 minus 3a plus 4b. So that will be minus 2a plus 4b, and then you find a value of a and b such that it satisfies the equation. അപ്പം നമ്മൾ ഇവിടെ a യും b യും കണ്ടുപിടിക്കുമ്പോൾ you can get infinitely many values for a and b. Choose any one such value for a and b. So here I have taken a equal to 2 and b equal to 1. So we will get x equal to 2 e raised to t and y equal to e raised to t as a solution of the linear system. Now let us find the second linearly independent solution. So the second independent solution is of the form, so that will be x equal to a1 plus a2t. So m is 1, so e raised to t varum, and y will be b1 plus b2t e raised to t. So dx by dt will be, so using product rule you will get a1 plus a2t e raised to t varum plus a2 e raised to t. So that will be a1 plus a2 plus a2t e raised to t. Then dy by dt, again using product rule you will get b1 plus b2t e raised to t plus b2 e raised to t varum, that will be b1 plus b2 plus b2t e raised to t. So that is the value of dx by dt and dy by dt. Now let us substitute the value into the given equation. So dx by dt will be a1 plus a2 plus a2t e raised to t, that will be equal to, so our equation was 3x minus 4y. So 3 a1 plus a2t e raised to t varum minus 4y. So that will be minus 4 b1 plus b2t e raised to t. Now the second equation will be b1 plus b2 plus b2t e raised to t, that will be equal to x minus y. So we will get a1 plus a2t e raised to t minus b1 plus b2t e raised to t. Now e raised to t will cancel out on both sides. So we will be getting a1 plus a2 plus a2t equal to, so 3a1 minus 4b1 plus 3a2 minus 4b2 t varum, and the second equation will be b1 plus b2 plus b2 t, that will be equal to a1 minus b1 plus a2 minus b2 t. Now let us equate the two equations. So we will be getting, so a1 plus a2 equal to 3 a1 minus 4b1, and a2 will be equal to 3a2 minus 4b2, and we will get b1 plus b2 equal to a1 minus b1 and b2 equal to a2 minus b2. So upon simplifying we will get, so we will get 2a1, so equation simplifying 2a1 minus a2 minus 4b1 varum, then we will get equal to 0, and here we will have 2a2 minus 4b2 equal to 0, and this equation will give 2b1 minus a1 plus b2 equal to 0. Equations are a2 minus 2b2 equal to 0, then 2a1 minus a2 minus 4b1 equal to 0, a1 minus 2b1 minus b2 equal to 0. So when we take a2 equal to 2 and b2 equal to 1, that satisfies the first equation, and from the, so upon substituting into the second equation. When we take the third equation, so we will be getting a1 minus 2b1 equal to 1 varum, and here upon substituting a2 we will be getting 2a1 minus 4b1 equal to 2. So that is the equation a1 minus 2b1 equal to 1. So let me take b1 equal to 1. So if I take b1 equal to 1, I will get a1 equal to 3. So therefore a1 equal to 3, b1 equal to 1, a2 equal to 2, b2 equal to 1. So therefore the second linearly independent solution is so that will be x equal to, so a1 is 3 and 3 2 varum a1 a2, so 3 plus 2t e raised to t, and y will be, so b1 and b2 will be, both will be 1, so 1 plus t e raised to t. Mean the first solution we got was 2 e raised to t and e raised to t. Now we can complete the general solution. So therefore general solution is x equal to c1 2 e raised to t plus c2 3 plus 2t e raised to t, and y equal to c1 e raised to t plus c2 1 plus t e raised to t. So that is solution for the linear system.